Today we're moving on to exponential growth and decay. We're going to start with exponential growth. The graph of an exponential growth function looks like this, where it starts somewhere above 0 and quickly goes up, kind of to the sky. Big thing we need to say here is it never touches the x-axis. So when you draw this graph, you never want it to start down here in the corner. It never starts at the x-axis. It always starts a little bit above the x-axis. Our formula for exponential growth is y equals c parentheses 1 plus r to the t power. Each number here represents, each letter represents something specific in a number. C stands for, can you tell it's a different color? Yeah, I think you can. Initial amount. R stands for the rate. And when we write our rate, we always are going to write it as a decimal. So we're going to have to turn this rate. The rate's going to be given to you as a percent, and we're going to have to turn it into a decimal. And then T is time. That's an exponential growth function. We also have exponential decay functions. Exponential decay are very similar, only it starts up and then it goes down. And when it goes down, it does also never touches the x-axis. So it gets really, really, really close down here, but it never touches that x-axis. Our formula for exponential decay looks very similar to the formula above, only it's 1 minus r to the t. These letters here, the C, the R, and the T, mean the same exact thing that they did above. We're going to be finding exponential growth functions by hand. We're also going to be finding exponential growth functions in the calculator. So right below here, we're just going to talk about what it looks like in the calculator. Y equals A times B to the x power. Where when we get this in the calculator, A stands for the initial amount. The B value is going to be our rate of change. Okay, and then x is still going to be time. If we are trying to decide if something is a growth or a decay, we're going to use this b value here, and we're going to do the b value minus 1. That's going to give us the decimal value, and we would then have to change it to the percent value. And that'll tell us, okay, that'll be our kind of like our guide to tell us if it's a growth or a decay. If that b value, if you just look here and that b value is greater than 1, it's going to be a growth. If this b value is less than 1, it's going to be a decay. So just by looking at the equation, we'll be able to tell if it's a growth or decay by if it's less than 1. Remember, values less than 1 are decimals. If it's greater than 1, or I'm sorry, I messed that up. If it's greater than 1, okay, which would be 1 point something, it is a growth. If it's less than 1 means decimals, that'll be a decay. If we're trying to find what percent of decay, that's where we're going to do this right here, b minus 1. Okay. So now we're going to look at a couple examples. And these examples that we're going to go over are what they look like when they come out of the calculator. So if we plug this into the calculator and I got this function, we're going to talk about what does this mean, okay? Or what can I do with this? How am I going to understand what this equation is telling me? So what does the base mean? Some of your questions might be asked, like, what does the base mean? Or it might say, what is the rate of change? Was this a growth or a decay? All these types of questions can be worded just a little bit differently. When we're talking about the base is whatever's being raised to the exponent. So this right here is the base of our function. So first thing we need to decide is this a growth or is this a decay? Well, because this value is less than 1, we see that it is a decay. So we can say decay at a rate of, and then we need to figure out what that percentage would be. So that's where we're going to follow this formula right here. The b value of 0.68 minus 1 equals 0.68 minus 1. We get negative 0.32. This is another way to tell if it's a growth or decay. Here it's negative, so that means it's going down. That's a decay. So negative 32, and I need to turn this into a percent, so I multiply it by 100, and I get 32%. You do not need to write a decay of negative 32 because we already said that it was a decay, which takes care of that negative. If you wrote decay of negative 32, you're going to be repetitive. And that's all you need to write for that one. So let's look at another example. Y equals 16 times 1.14x to the x power. And again, the question's asking the same thing. What does the base mean? So here we're going to look, does this value here, this base, is this base greater than 1 or less than 1? We can see that 1.14 is greater than 1, so that means that it is a growth at a rate of, and now we subtract 1 from it, 1.14 minus 1, and that's going to give us our percent. 1.14 minus 1 is 0.14. Multiply it by 100 or move the decimal 2 places to the right, and we get 14%. So it's a growth at a rate of 14%.